Objective: to solve problems involving ratio. What's a ratio? Well, a ratio of one number to another is the quotient when the first is divided by the second, and the second is not zero. Remember, peeps, you can never divide by zero. You can write fractions in three ways. You can write ratios in three ways. You can write it as a quotient using a division sign, like 7 to 4, as a fraction, like 7 to 4, or as a ratio using a colon, 7 to 4. Right? You use ratios to compare quantities of the same kind. Meaning they must be the same unit. I can't say, oh, 3 hours to 30 is the ratio of 1 to 10. They need to be in the same units. So I can either say, change the 30 minutes to one half of an hour, or I could change the 3 hours to 180 minutes. So I need them, these to be the same. So I'm going to rewrite this guy. Instead of 3 to 30, I'm going to write it as 180 to 30. And now I can reduce this. Right? This is 18 times 10, so I have 10 over 10, get rid of that. And since this is 3 times 1, this is 3 times 9. I'm sorry, 3 times 6, I get 6 over 1. So 3 hours to 30 minutes is a 6 to 1 ratio, or a 6 to 1 ratio, or a 6 to 1 ratio. Right? What about 4 feet to 10 inches? Well, how many inches are in a foot? 12. So how many are in 4? 48. So I'm going to write this as 48 to 10, which is the same thing as 24 to 5. Isn't that nice? I took half and half. Same thing as reducing a fraction. Okay. Let's look at some more ratios here. 48 pounds to 36 pounds. Well, pounds cancel. Just like x over x. Well, yeah, the ratio doesn't, there's no units in that ratio, you know what I'm saying? 48 is to 36. Well, isn't 48 12 times 4? And isn't this 12 times 3? Notice what happens. I end up, I get 4 to 3. 15, 45, you know that goes into it 3 times. It's a 1 to 3 ratio. Right? This is 15 times 1. This is 15 times 3. 1 to 3, 1 to 3. And 40 centimeters to 3 meters. This is a 40 to 3. Wait a minute. I see centi. I see me. How many centimeters? You think of the centimeter. Yeah, a meter stick, right? How many centimeters in there? Not a million, not 1,000. It's 100. So 3 meters is really 300 centimeters. I have 40 centimeters over 300 centimeters. Well, the zeros cancel out. So it's really a 4 to 30 relationship. Or we could have said, alright, 40 centimeters is 0.4 meters over 3 meters. Centimeters cancel out. Meters cancel out. Now I have 0.4 over 3. Multiply this by 10 over 10. We don't like decimals in a fraction. And I end up getting 4 over 30. So this decimal point that was right here, they slide together on the numerator and denominator. Whee! I get a 0 there and 4 over 30. I don't know. Do you say "we" when you slide decimals? I do. Well, obviously, you just heard me. All right. So when you have to solve a word problem, you may have to express a ratio in a different form. For instance, if I say the lengths of the sides of a triangle are the ratio 3 to 4 to 5, the perimeter is 24 feet. So I know that it's a 3 to 4 to 5 relationship. So actually, that should be a right triangle. But anyway, I have 3 things to 4 things to 5 things. Just like up here, it's like, oh, you know, I have a 4 to, where is it? A 4 to 3 ratio. It happens to be 4 12s to 3 12s, but it's still a 4 to 3 ratio. Here I have 4 12s, 3 12s, right? And here I had a 1 to 3 ratio. I had 1 15 to 3 15s. Okay, there's a 1 15 on the top, 3 15s on the bottom. So it was 1 of something to 3 of something. So when I look over here, I can have a ratio of 3 to 4 to 5. It could be 30 to 40 to 50 or 15 to 20 to 5. Here I have 3 10s to 4 10s to 5 10s. Here I have 3 5s to 4 5s to 5 5s. So when I don't know what it is, I could say I have 3 blobs to 4 blobs to 5 blobs. We don't like to say blobs. So I just put an x in there. So I have a 3x to 4x to 5x relationship. So now, when I have 3 of these things, that will actually be the length. 3x is now the length. And to find the perimeter, just add these lengths. When I put this x there, it turned into length. So this number, 3x, is the length. So this length plus this will give me my perimeter. 3x plus 4x plus 5x is 12x. My perimeter is 24. X is 12. So what are my numbers? Well, if x is 12, this is 3 of them. 36. Oh, wait a minute. 2. Oh my goodness. 2. 3 2s is 6, 8, 10. Do they all add up to what I want? Yes. Is it still a 3, 4, 5 relation? Sure. Nice. Here's a little word problem for you. Okay. Concrete can be made by mixing cement, sand, and gravel. 3 ingredients: cement, sand, and gravel mixed together to make concrete. In the ratio of 3 to 6 to 8. How much gravel is needed to make 850 cubic meters of concrete? I'm not going to go all the way through this problem. We're going to set it up. Well, if the ratio is 3 parts to 6 parts to 8 parts, I can write it as the cement is 3 parts, the sand is 6 parts, and the gravel will be 8 parts. I need to make this much total of concrete, so the amount, once I put the x here, if it's 3 parts, 3x gives me the amount of cement. 6x is the actual amount of sand. 8x is the amount of gravel. The volume of each one of these will add up to the total volume, 850. When I add this all up, I get 9 and 8, which is, nice, 17x equals 850. And then divide by 17. Right? Very nice. And that'll find what your x is. But if I want to know how much gravel is needed, which one's gravel? 8. I take this, multiply by 8, and I get my answer. Because 8 of those things, 8x. That's the amount of gravel. Alright, we move along, run out of time here. To find the ratio of x to y, sometimes they say, can you find the ratio of x to y? Well, to find the ratio of x to y, you do not want to solve for x, you don't want to solve for y, you actually want to solve for x over y. So you want the ratio x over y on the left side or the right side of the equation, and then some other fraction on the right, so you can set up they have this proportion. So we want x to y on one side, so here I'm trying to get x over y on one side. They give you a hint in the book, and it's a great hint. It says, collect the x terms on one side of the equation and the y terms on the other side of the equation, factor, and then solve. Nice, that's what I'm going to do. How am I going to do that? First I'm going to what? Yes, distribute. I'm going to have 16x minus 24y equals 6x plus 6y. I'm going to collect all the x terms on one side, so I'll bring this over as a negative 6x, 16x minus 6x. And add this 24y to both sides, so I get 6y plus 24y. And notice, 16x minus 6x is 10x. 6y plus 24y is 30y. Almost done. I want to know what x is to y. Well, if I can have it looking like this, x over y equals something over something, I'll know what the ratio is. So let's see. I have an x here. I want to get this y down there. If I multiply both sides by 1 over y, these cancel out. And I multiply this by 1 over y. I get a y down there. Nice! If I multiply both sides by 1 over 10, I get rid of this guy. So I have to multiply this side by 1 over 10, and my 10 comes down here. The 10 came from up here to down there, the y up there to down there. Now I have my x over y equals 30 over 10, which we know is a 3 to 1 relationship. X to y is 3 to 1. Let's do it again. Solving for x to y. Alright? Here we go. Get all the x terms on one side, the y terms on the other. Take this bx over here and I get ax. Take this negative ay squared, add it over here, a squared y. Take the bx and bring it over here, minus bx. Okay, so I brought this guy on this side, bring this guy over here. I get equals a squared y minus b squared y. And what do I end up with? Scratch my head for a second. Factor the x out of the left. Factor the y out of the right. Alright, I want this bx over y. I'm going to multiply by 1 over y. By 1 over y, and the y comes down here. Alright, 1 over y cancels this out. 1 over y comes here. And I multiply by 1 over a minus b. 1 over a minus b. Those cancel out. 1 over a minus b on this side. Get an a minus b here. So I get my x over y is the ratio of this to this. Almost done because I haven't factored this yet. This is actually a minus b, a plus b. And what happens to my a minus b's? They're gone. I end up with x to y is a plus b to 1. Make sure you remember the restriction here. I had an a minus b in the denominator, therefore a cannot equal b, because if it did, this would be 0. And that's a no-no. Alright, that was a kind of a crazy one. I'm going to talk about some ratio cool stuff after.